Alright, this exercise asks how many perfect squares are there between 50 and 500? So, just like always, we can just start listing them out. Now, I know 7 squared is 49, but that's not quite big enough. So let's look at 8 squared. That's 64. And 9 squared would be 81. 10 squared would be 100. Alright, and we want to go all the way up to, but not go over, 500. So let's try to figure out what's the biggest perfect square that doesn't go over 500. Well, I would probably start with 20 squared, which is, whoops, I shouldn't write 20. I should write 400 because 400 is 20 squared, right? So 400 is a perfect square. So that's 20 squared. 21 squared. What's 21 squared? 21 times 21, we get 21, and then we get 42, so 441. So that would be 21 squared. It looks like we could probably go bigger than that. So how about 22 squared? 22 times 22. That shouldn't be too bad. 44, 44. So it looks like 484. Alright, I think we're close, if not there. So 484 is the next one. So let's try 23 squared. I'm guessing that's going to be, whoops, that's going to be too big, but let's try it. See what we get. 23 times 23, so that's 9, 69, and 46. I can see already that that's too big. That's going to be 529, so that's way over. So it looks like our biggest one is 484, which is 22 squared. Okay, so the first thing that we probably want to do is get rid of the square rooting. Now, get rid of the squaring. We can get rid of the squaring by taking the inverse operation of squaring, which is a square root. Okay, so if you look at now I know a lot of the other exercises we've looked at the difference between consecutive numbers, but if you do that, in this case, you don't get a common difference. You don't get a the difference between consecutive numbers is not a constant. So like here you can see this is 41 and this is less than 41. So we don't get a common difference. So this is not an arithmetic sequence. But we can still count this list because when we undo the squaring, we get 8, 9, 10, all the way up to, we said, 22. And that's easy to count now, right? Because it's already a list of counting numbers. We just need to shift it so it starts with 1. So if we subtract 7, we'll get 1, 2, 3, all the way up to 22 minus 7. I think that's 15. So 15 is our answer. Okay? So even though it's not an arithmetic sequence, you just have to undo what we did here. We squared numbers, so if we unsquare them, unsquaring is square rooting, and we get our answer, 15.